Hi, so today I just want to show you how to get started with Capture the Ether, which is a hacking, kind of like an Ethereum smart contract hacking tutorial. So I highly recommend spending a lot of times on learning how to hack smart contracts because it makes you very good at understanding how these hacks work and thus a better programmer because you know what to look for when you program the code yourself. So, if you are, working towards becoming a smart contract engineer, a blockchain developer, definitely spend at least a couple months and even regularly train basically on these hacking exercises. So, there was one series of hacking exercises called Ethernaut that was running on the Ringabit testnet, but that is being deprecated now. So I think they'll need to move that over to Gurley. But there are other hacking solutions out there, and actually today we're going to take a look at another one called Capture the Ether. There are others, and I'll in upcoming videos I'll show you how those work. But let's take a look at Capture the Ether and basically how you get started with that and how you get set up. And feel free to send me any questions if you have any issues with it. I'm Crypto Jesper K, so feel free to follow me on Twitter, on this YouTube channel as well. Feel free to give it a like if you like the content and if it's helpful. So, all right, so let's see. If you go to capturetheether.com, this is basically what will show up. So it's a pretty simple UI. You'll just see this button, Let's Play. All right, so we'll click that. Note that this does not work in the Brave browser. I personally like the Brave browser quite a lot. I work in it quite a lot, but you cannot use this in the Brave browser. So in this case, I'm using Chrome. But all right, so we go into the challenges when we click Let's Play, and there's some warm-up exercises that I definitely recommend you take a look at. Let's take a look at one here, deploy the contract. Or deploy a contract. Now, of course, I've done most of these, so it'll kind of show us as a strike through here in the text and a little check mark. For you, it'll probably say something like deploy contract or something. For me, it'll always say do it again. But I'll just do that on some of the exercises. So we'll just go through some of these exercises. I'll show you how to use Remix as well to kind of set up your separate hack contract and use that as part of your hack in general. Okay, in some cases it might not be necessary to use Remix, but I found it pretty, like most of them need it. Anyway, so as they're saying here, you gotta install MetaMask. I have it. You see this little fox up here, MetaMask, so just make sure you install that. You gotta be sure you're on the Ropsten test network. So when you go here, I have selected my account in MetaMask, and I am on the Ropsten. I have a bunch of networks here, but I want to make sure that I pick Ropsten test network. Note this little toggle here. It says show hide test networks. You want to make sure it's actually showing the test networks, because it might be that when you just install MetaMask, you won't see any of these test networks. So you want to make sure you say show test networks. All right, I have about 2.5 Ropsten ETH. You'll need to find a faucet to get ETH, and that's what they're explaining here. So make sure you have some ETH in your account. Cool. So in this case, all you have to do in this exercise is just literally deploy this contract. And the way they're also describing is that each hack contract will have this is complete function. And your goal is to make that return true. As you can see, this always returns true. So this is, again, just a test deployment contract. So pretty easy to pass this level. All right. What we're going to do is jump into one it's not difficult, but it's a little bit more challenging. Guess the number. So this is also just meant as like an early exercise here. So, okay. What you'll find generally in these challenges is that you have the title over here, guess the number. You have how many points it gives you. So you can see I don't have that many points, but like 4,500 points. I think the leaderboard is like definitely at least double that, if not much more. I forgot the exact number, but actually we can take a look. The leaderboard is like, 3 times that. So But anyway, that's just to tell you what this number is about. So these are the points. You can see how many points you have up here, so how many you've done. All right. So they also have typically a link to some funny stuff here, like some music or something like that. And then, comes this button where you can actually deploy it. You need to click this. It'll open your MetaMask, and it'll tell you to deploy it, and you just confirm. And once it's done, and we'll see this in a second, it'll show you the actual like instance address, the address of this contract you're seeing to the right here. Okay, and then it comes with a description, like what they want you to do. And in this case, they're saying, I'm thinking of a number. All you have to do is guess it. So we can kind of read through the contract and see that, well, the contract is called Guess the Number Challenge. It has an answer, which is given at 42. That seems interesting. Maybe that is the answer. Then it has a constructor. This is the old way of writing a constructor, by the way. You also notice that the Solidity version is pretty old, 0.4. So that's a drawback of these. But I guess it's good that you also learn like an earlier version. We're at 0.8.16 at this point. So it's a lot has happened since 0.4. But it's still good just to see the old version and kind of what were some quirks back then as well. Because you won't always be guaranteed that the contract you have to audit or work with is exactly 0.8.16 that you're most comfortable with. But anyway, the point is just to say that this is actually the constructor. One of the challenges will show you why this is not called, no, that was actually Ethernaut, but one of the Ethernaut challenges show you why they changed this so that it's not just the function that's called the same as the contract. There's a specific constructor function now. Anyway, this is the constructor. You'll notice that every time you deploy this, no matter what the contract is, like this is guess the number, but there are other challenges, it'll require you to deploy it with one ether. So it'll kind of lock up one of your test ethers, Robson test ETH, and only give it back to you when you solve the challenge. So you want to be a little bit careful here. Some challenges have state that changes so that if you deploy this with one ether and you kind of mess something up because you're not completely you haven't completely thought about the solution, so you're just trying to play around and some state gets messed up so you cannot really revert, you have to redeploy another instance, and you can, but my point is then you're going to lock up another ether and you lose the initial ether and so on. So like you want to be careful and make sure you just have the solution before you actually like lock up this ether in general. Now this is an example where it doesn't matter too much because there's no state that really locks you out, so to speak, but just be careful. Anyway, and I mean it's just test ethers, you can always get more, but just FYI. All right, so we need to lock up one ether when we deploy this. That's common for all of them. Now, I was talking about this is complete function that is also common for all of them. That is the one we need to make return true. That's how they check the solution. When you click check the solution, you'll see the button in a second. All they do is check is complete, and if that returns true, you're good. Now you can see this time it doesn't just return true. It says, is the balance of this contract, like basically this instance, once it's deployed, is the balance of this instance 0, right? And of course it won't be 0 in the beginning because we literally just deployed it and sent one ETH to it, so it definitely isn't 0. It will only be 0 when we solve it, and you'll see how. So in the guess, that we can kind of guess, no pun intended, that that's the function we gotta interact with, right? Because we gotta guess a number. So sometimes the hints up here are just kind of, they're not direct, like they don't say call the guess function with your guess, they're just kind of like a little playful at times, but that's okay. So anyway, the guess takes in a uint8 variable called n, and they're just checking is n equal to the answer, and if it is, then transfer 2 ether, right, the one that was initially locked up on construction, and then the other one has to be sent with this guess. So when you actually call the guess, you send another ether. But anyway, if you guess right, it'll send back the 2 ether it's holding on to your account. So you're not really losing any ether here. It gets sent back to you. But notice that, you do have to send one more ether when you call this, okay? And then you'll notice that, well, since it has 2 ether, it just sent 2 to you, well, the balance must be 0, so that's what makes it complete. Okay, now, so that's just the overall structure of all these challenges. The next thing, of course, is then to figure out how to solve this. This one is pretty easy because the answer is right here. It's 42, so we know what to guess. But I just want to show you how to then do it. What I recommend is going over to Remix. So go to Google, search for Remix. And what you can do is just import the contract over here. So what we're going to do is call it guess the number challenge. So I'm going to create a new contract called guess the number challenge. That's Solidity. And I'll paste all this in. And it might just give you an error in the beginning because it's complaining about the Solidity compiler. But you just want to make sure, see, it's defaulted actually 0817. I set the latest 16 before, it's actually 17. You just want to make sure you switch that back to 04. So you also see that it has this, you know, kind of hat there. So that means that it's good from 0.4.21 up. So also 26. You can also select a specific one. Doesn't really matter. I'm just showing you kind of like what are some options. Anyway, so you can click compile. So now this is compiled, this code, and we see that it compiles fine. What you can then do is you can, in the challenges that require you to build another hack contract to hack this challenge, you would then just build another contract here, right? You know, just add another one called hack or something. And then you can use the VM in here to, you know, carry out your hack, test it, make sure it works again. And then once you know it works, you will then actually go to Ropsten, go to MetaMask, and deploy these, or at least interact with the existing deploy contract. So let's actually go through this flow right now, how we do it. So let's try to hack it right now. We're in the virtual machine, in the Remix virtual machine, the London fork. We are given some accounts, each with 100 Ether, as you can see. This is just standard Remix stuff. What we're going to do is we can click this file up here, guess the number challenge. This will show the code as we expected. Great. Now we're presented with a deploy button that's red. That's because it needs it's payable. You can send funds with it, and we know we have to send 1 Ether, right? Like if I try to deploy right now, it'll give me an error and revert. You see that here, and that's because we did not send 1 Ether. Okay, so let's do that. Send 1 Ether, and I'm just going to pick the first account. Click deploy. Now you see we deploy it. Okay, now we can go look at the contract, but it's deployed in the virtual machine. Okay, so just locally in our machine, or like locally in this instance, I should say, in the browser. Get rid of that. All right, so it's deployed, and we can click is complete, and of course it's false because we haven't made a guess yet. You also see up here the balance, it says, of the contract is 1 Ether. That's the 1 Ether we just gave it when we deployed. The goal is to get that balance to 0. All right, so let's put in a guess. First, let's guess 20, okay? Now, that should fail, right? I mean, it shouldn't fail, it should run, right? But it shouldn't make is complete true. So let's guess 20, okay? So if we guess 20, this code is being run. It requires us to send 1 Ether. Yeah, we did send 1 Ether. And if n equals to the answer, then transfer 2 back to us. As you can tell, that's not true. Okay, this is still... this is 2 Ether now because we actually sent 1 Ether to it. And 20 is not the answer. 42, however, is the answer. So if we click that guess, we just got to make sure we send 1 Ether with our guess. We send a guess. Now, notice something here. You know, is complete is false. Now, why is that? So we guessed 42, which is the right answer. But because we had just guessed wrong, like with 20, we also sent 1 Ether to the contract. So our balance was actually 3 Ether. And then after that, we guessed right. We guessed 42. And then the balance, it would send 2 Ether to us. Notice it doesn't transfer address of this .balance. It just transfers 2 Ether. So it's important that you have exactly 2 Ether in the account by the time you solve it, okay? So I'm just showing you this to show you like some of the quirks you want to make sure you don't get into, because now you see this is complete as false, even though we guessed right, but that's because we can't transfer more Ether out of it. Now, what we could do is we could just guess again. I'm just showing you, like, my point is, like, you want to make sure other challenges get more complicated. You want to make sure you don't get all this, like, locked up in these contracts, right? Because it can be a little bit annoying. Now, we can actually just send 1 more Ether and guess 42 one more time, and we're good. Okay, so now it's true. So what I did there was just send another Ether and guess the same as it just did, which is 42, and then it transferred me back 2. So, I mean, it didn't go as bad as it could have. Okay, cool. So that's this, and now is complete is set to true. Okay, fine, but this was all in the VM. We need to actually solve the actually deployed contract. So what we're going to do is I'll click do it again. Yours will probably say something like deploy. So I have my account here on the Robston network. I'm going to spend 1 Robston ETH to actually deploy this. So it just told me that 1 Robston ETH plus some gas, and it'll deploy. So we just wait a little bit for that to deploy. Okay, great. So it's deployed. And they're telling us the challenge contract, so this to the right, is deployed at this address. Okay? And we can click start over. So if something gets locked up or messed up and you can't really restore the state and you just want to start over, you click there. But note that you will lose 1 ether. Okay, so ideally you don't do that. And then the check solution, again, on their end, they're just calling is complete, make sure it's true, and that's it. But only call this when you have like actually solved this, of course, right? So, okay, anyway, my point is, what you can do is you can copy this, that's the instance address, and you can go over here in Remix, and what we're going to do is we're going to clear out everything. We're going to switch over. Notice this, you can kind of switch your environment. So right now we were in the kind of local virtual machine. I want to switch over to MetaMask. So this actually means, look at this, we're connecting to MetaMask, this here. Notice my account is like 1117. Notice over here it's 1117 in Remix. So this is, I'm actually connected to Remix, to the actual Robston network. It'll tell me below as well. And on the right account. Just double check all these things, but that's how it looks. So I have 1.5 Robston ETH. I started at 2.5, but I just deployed that 1 contract. So now I'm down to 1.5. So I want to get that back. So let's solve it. All right. What I want to show you is you can, for the VM, we deployed this, right? We clicked the deploy button and we kind of deployed a new instance and everything. Remix also has an option. It says, look at this. It says or, so you can click the deploy, or you can like kind of load this contract. So you're telling Remix what contract it is. That's what's happening to the right. And then you're saying, hey, this contract is already deployed at this address. So you could just click add address. Okay? So now you're connected to this specific test contract, the one we actually want to solve, right? So you can expand that just like before, and it'll look the same because, of course, it's the same contract. Okay, is complete. We can check it. It's false. When we click this button, MetaMask did not show up because it's just a view function, right? You see here public view, so we don't need to like run anything. Like it's not a transaction we need to send and mine, right? We're just looking at the state. Okay, fine. Let's send our guess. Notice that the balance is 1 ETH. That's great. We want to guess 42 because we know the answer is right up here. And we want to send 1 ETH with that. And again, this is the actual MetaMask. Now when I click this, it will mine a transaction. So it'll send up MetaMask to send out a transaction to be mined to the network. So I'm going to confirm. And notice here now, first of all, these transactions aren't instantaneous because we're not in the VM anymore. It'll say, oh, pending. So note, just because this, look, if I do is complete, it'll say false still. Okay, even though the guess is right. But it's because it hasn't been mined. Look at the check mark. Now it has been mined. You can also click this and view on Etherscan in the meantime. You see this successful has 1 confirmation. So that's just how it works in Remix. Sometimes it can take a little while, so you just got to wait. Now, anyway, it's been mined. It says I have a check mark. I see the balance real quick here. It's 0 ETH. That's a good sign. If I now click is complete, it better be true. It is true. That's good. I check my own balance. I'm back at 2.5. Well, that's good. We're all restored. And it's true. Now, great. So this is the actual contract from over here that you have solved now. So now you can click check solution. And you can click confirm. And now it'll just take a little second here to call this is complete function. And you'll see a little dancing avatar come up when it completes. There you go. You did it. Plus 200. Okay. Now, I didn't get 200 because I had already done it. So they did prevent me from getting multiple points there. Okay. So that was just a simple one, guess the number. There are more advanced one. And one thing I want to show you also, a little gotcha, is here. Some of these... predict the number. Basically, they're showing you how difficult essentially it is to implement a lottery on the blockchain because it's very public. Everybody can see the state variables or create smart contracts that can call your lottery and thus get access to various state variables like block hash and block number and all this kind of stuff. So it actually gets a little bit difficult to do in general. Companies like Chainlink have really good kind of solutions to this. You suffer slightly in decentralization, I guess, if you really want to be a decentralization maximalist, which is fine, but it makes it, they make very, very good practical solutions. Okay, so they have these things like verifiable random functions, things like that you can use. Well, anyway, what I just wanted to show you is a quirk with Remix that if you have something like block hash, okay, so what I'm going to do now is notice that for some challenges it uses block.block hash to do something. And in some of these challenges, you need to create another smart contract that also uses block.block hash. So if you need to use that, you're going to run into some issues, and I just want to show those to you. So unrelated to that, to this hack I just showed you over here, I just wanted to show you, the point is just you're using block hash. I want to show you how block hash behaves in Remix. So we can just take the same contract we had before, and what I'm going to do is have this function, let's say this guess function, okay, and I'm just gonna call. Okay, so when you actually call this function here and you catch the answer, so the answer will come back as bytes 32. Again, we're getting the most recent block hash, so you would think, okay, there's probably not a lot that can go wrong here. But when you actually click guess, what's going to happen when you're in the VM is that it's just going to hang. It's just going to say transact to hack.guess is pending, and it's never going to complete. And this is just because of the way how the VM works. It'll just never finish this call. So when you get to those hacks, those challenges, it's going to be difficult to complete them because you can't run these in the VM. What I recommend is you use Ganache. So install Ganache and you can open it. So just go on Google and say Ganache crypto or something, and then just like make sure you install it. And you can install the desktop version as well. You can also just do the CLI, so like a command line interface, and you can just go into the terminal and use it from there. Or you can just do this desktop version. So you can just say quick start Ethereum, and it'll quickly spin up for you a local blockchain, but in Ganache. The reason why this will work with block hash is because Ganache is actually mining the blocks, so they get a block hash and so on, and it's actually mimicking mining in the background. So you'll notice a couple of things. One is the current block over here. It'll tell you. It will also tell you what server it's running on. So it's running on your local host, which is 127.0.0.1, and the port is important just to note. I'll just copy this whole thing, but if you go over here, you can then select Ganache provider. So if I do that, it'll automatically try to get to 8545. In my case, I guess this desktop version is doing 7545, so I just gotta change that, and I click OK. Now you notice that I'm actually on using Ganache as my provider. Okay. So just like before, when we kind of switched over to Ropsten testnet via MetaMask, I'm just using Ganache here, my local network. Okay. Sorry. Open this. Okay. So what we can do is deploy. Now when I click deploy, I'm gonna deploy in Ganache. Okay, there you go. So there was a little bit of delay just because Ganache just had to mine it and everything, which is, I mean, it's pretty fast still, but technically there's a little delay. It'll tell you the block and the transaction index. So basically, which index in the list of transactions that this one was. Okay, now let's try again. So remember last time it just kind of went into this pending state, but if I click guess now, it actually comes back and it completed. So that's how you can get around that and still test it locally. So one more thing I just want to show you is that, let's say that we actually did create a hack contract to hack guess the number challenge. So right now we just did it manually, but let's now actually try to create a contract that hacks it, because I just want to show you some things that you can, that that are kind of consistently showing up when you do have to use a contract to hack, which is pretty often in the other challenges. So what I mean by that is the general way you do it is you create your hack contract like this. You start it from scratch, and then whatever challenge you're working with, get it over into Remix, create its own file, and what you can do is either import that file, or you can create an interface. So I'm going to show you both approaches. So you can do this. You can just import guess the number challenge. Okay, so you can do that. All right, and now you have the interface. So the hack contract knows what guess the number challenge, like what the contract is, what kind of methods it has, and so on. So what you can then do is just create a function called hack, for example, and basically you can point to this challenge. So guess the number challenge, guess the number, and basically now the way it's going to work is that we're going to call hack. We're going to pass in the address of guess the number challenge, and what we can do is this. So we're going to actually hack it. So that means we're going to call guess, okay, on this contract. All right, and we're going to pass in 42. So that's the hack. Now after this, it is complete, is true. But notice one thing. In guess the number challenge, when we deployed it, we sent 1 ether to it on deployment. When we guess, we send another ether to it. So it'll actually end up transferring 2 ether to message.sender, which is like message.sender in the guess. Okay, so what I'm saying is this contract called hack will receive the 2 ether, and we need to actually just forward that. We can just forward that right to the sender, the player address. Okay, so what I mean is when we have done the guess from the contract, notice that there's us, the player, there's the hack contract, and there's the guess the number challenge contract. The hack contract is now what called guess. Before it was us, we called the guess directly in the main contract. Now we use this intermediary contract, hack, to call the guess. You see right here. Okay, so the challenge is going to say, hey, you guessed right, and it's going to send 2 ether to message.sender. Message.sender, though, is the hack contract, not us. It's the hack contract. So the 2 ether is going to go to that contract. So, but we can forward that directly to us. tx.origin is us being, the hacker. And we're going to transfer just all the ether that's in this, which would just be 2 at this point. Okay, so we're going to hack it. And then this contract is going to get 2 ether, and it's actually just going to forward it to us, basically, because tx.origin is whoever, that's the human account that called this, which is going to be us. Another thing we can just do as well here is, which is kind of neat, we can actually just check whether it even completed, and we can require that. So we can just say, actually require that we actually hacked it correctly. So now we know, and then after that we just transfer the balance, and that's it. So this is the exploit right here. So this is the exploit, and this is just kind of, checking our solution and sending ether back to us. Okay. In this way, we don't need a separate withdraw function. Another thing we also just want to make sure is that this contract can receive ether. Okay. Because when the challenge contract sends ether to us, again, it's the hack contract that'll receive it, so we want to make sure it can receive it. The way you do that in Solidity is you create a payable fallback function. In more recent versions, like the receive function, that you can also do when you only send ether to it, but right before. So what you do is so we need to actually send some ether with this. So the way you do that is like this. Okay, so you do right before, at least in Solidity 0.4, you do the contract address, you do the function you want to call, and then you do .value. So this will send whatever amount you basically specify to the value, and then comes the parameters to the function you're calling. Okay, so let's recreate hack. And yeah, now we actually need to make this payable as well, and we need to say require message.value equals 1 ether. Okay, so we just want to make sure that is the case, that we're actually sending 1 Ether there, and that's it. Let's redeploy that. Okay, so now we take this contract address, we deploy it here, we send 1 Ether along with it, and we hack it. That's it. So guess the number challenge is 0. It's complete is true. Okay, and we are back at 99.98, so we have our Ether back. So that's how, in general, you can construct these hack contracts, and in general, the exploit will go here. So whatever the challenge is, you just put that right there, but the rest of the skeleton around it is pretty much the same. You do the exploit, you check it's complete, and you transfer the funds back to you. That's it. So you can kind of use that. Okay, all right. I hope that was helpful. So, yeah, that's that's kind of how you do the capture the Ether challenge. So yeah, happy hacking, and you know, I really hope you learned something here in terms of how the hacks work and how you can make sure your contracts are not hackable, or at least minimize that risk, and also get it ready for audit. So yeah, let me know if you have any questions. Let me know if you found this useful, or what you'd like to see more of or less of. Yeah, thank you very much for watching.